The ABISS is an autonomous biogeochemical in situ sensing system. That's the acronym. And what it is it's a scientific platform that we can leave on the bottom for days to weeks at a time and perform scientific measurements with chemical sensors in near real time and be able to recover the data with an optical modem.
So on ABISS, the optical modem lets us retrieve all of the data we have measured, all the data we've collected, the mass spectrometry, without physically retrieving the instrument or connecting to the instrument. Communicating underwater presents an interesting challenge because the water blocks most electromagnetic radiation except for visible light, essentially.
So the timescales that I think we can really apply the ABISS best to are on the order of about a year max. And so currently what our limiting factor is the power budget.
Battery power is a crucial issue for any of these measurements. We know how to do a lot of measurements in the lab, and it's an extreme challenge to take all that you know and how to do in the lab, where you have the luxury of plugging into a wall socket, and take that and sink it deep into the ocean.
As scientists, we're pretty good about understanding the spatial scale of things going on in the ocean. We go to places with ships and we make discrete measurements at these very fixed locations for very short periods of time. And so what we're doing with the ABISS is we're shrinking that spatial scale drastically to a really small point, but greatly increasing the temporal scale so we can understand more how these processes evolve over time, because honestly we have a very thin grasp of how a lot of these things are controlled in time over even days to week timescales.
So in the context of this 2-day deployment, it may not seem like much, but once we push a deployment length to a year, for instance, then it becomes very advantageous to be able to just go down there and get the data and leave the instrument in place.
When you're wanting to transmit images from the autonomous vehicle to, say, an ROV, or you want to transmit very long log files that you've been in long time series, important time series for the study, it really makes it much better to have this optical link. In this application, we have the luxury of having the ROV just drive right up and make a really strong link. So the technical challenges on the optical modem side were fairly limited for us, which is actually fairly convenient.
What we're really hoping to resolve with this type of data, particularly the site we just completed a deployment at, is we want to understand more about what controls these temporally variable bubble streams. And so being able to sit in place and measure this for 2 days will be very sensitive to the changes in methane that come out of this venting location.
I think this cruise went really well. We're leaving with a lot of data. We're leaving with hopefully some answers, but I think we're also leaving a lot of questions. One thing that really surprised me on this cruise was how hard it was to sometimes find the bubbles. We would see them in the multi-beam and we would dive on them, and sometimes they weren't there. And then a few hours later they would be there. And it was more surprising to see that in real life than to read about it. During this cruise, we had physicists, biologists, chemists coming all together to be able to measure those methane bubbles. Some of the things we brought out worked really well, better than expected. Other things had challenges that another week at sea probably would have helped us to be able to get through some of those. What we're leaving with is really the idea of what worked well, but what didn't work, and we can go back to our lab and then improve upon them. The RV team was fantastic. When we told them the crazy ideas and crazy things we wanted to do, they did it. They did it with a smile, and they helped us to make it better. We asked them to do some crazy things, and every time they did it with success.